Good morning, my dear students. Today we are discussing about interesting topic known as oscillators. Nothing but without any input signal, it is used to generate AC output waveforms. Nothing but pulse. Another one is a square. Another one is a sine. Okay. For this, we required for oscillator a tank circuit as a feed tank circuit. Another one is a feedback element in order to generate a sinusoidal waveforms at its output. Okay. Now the tank circuit like this on one inductor, another one is a capacitor. This is a tank circuit needed for oscillators. Oscillators are mainly dependent on two sessions. First one RC, next one is LC. RC means nothing but audio, where LC means nothing but radio. Okay, you move on or block diagram for an oscillator. You take a simple switch. Again, another one is one amplifier circuit. Another one is one feedback element. Nothing but beta. Okay, this switch, if the S is closed, then the circuit will be conduct. Oscillations will occur. If S is open, the circuit will not conduct, so that the oscillations will not occur at its output. Already you have known that A is equal to V naught by VA. Nothing but V naught is equal to AVA. Again, beta is nothing but feedback factor. It is ratio of feedback voltage, nothing but VF by V naught. Nothing but mm, VF is equal to mm, VF is equal to beta V naught. Okay. Again, V naught be replaced by beta into AVA. Okay. Now you move on to our Barkhausen criteria condition. Every oscillator is used to depend upon this Barkhausen. Nothing but modulus AV beta is equal to 1 factor. Another one, angle AV beta is equal to 360 or 0 degrees. Angle 360 or 0 degrees. This is a Barkhausen criteria condition. Next we move on for in this we are having three types of circuits. First one is RC phase shift oscillator. It been constructed with BJT. Another one is FET. Another one is op-amp. Okay. Already I am taking simply an op-amp. And this non-inverting resistor has been grounded with a resistor. A feedback resistor is connected from RF. Another one is connecting. I am connecting three sessions, nothing but three RC sessions as it feedback. Omit the feedback. Okay, 2, 3 are inverting, 7, 4 are positive. You already know, and output we are measuring at this. Okay, entire circuit can be driven by using hybrid equivalent model. Already we are having 4 parameters. Out of 4 parameters, we are having only 3 parameters as its output. Okay, we are having three sessions, three RC sessions. Okay, nothing but when first flowing current is I1, second flowing current is I2, and third flowing current is I3. I am talking about I3 session. Nothing but I2 is equal to I3 into 2R minus JX. C means JX. Okay, like that I am writing. And I2R is equal to same I2 is equal to I3 into 2 by R 2 minus JX by R. X by R can be written as alpha. By solving these equations, we can get substitute this equation in 2 and 3. We can get the frequency as 1 by 2 by RC. I am not deriving all the equation, simply writing the resultant equation. This is the resultant equation. Oscillator is used to depends upon first one is frequency, another one is condition for sustained oscillation. Okay, in every oscillator we use to derive the two factors. First one is frequency, another one is condition for sustained oscillation. And these three RC sessions are being taken. RC is used as a time constant. For each session, it is used to generate a phase shift of 180. Nothing but three sessions means 3 into 60, nothing but 180. Another one is off amp is used to provide another phase shift of 180. Therefore, total phase shift in the circuit is 360 or 0 degrees. At this particular frequency, the oscillator can be oscillate to produce oscillations. Okay, to move on, next one, Wien bridge oscillator. Wien bridge means it is a Maxwell, nothing but derived by Maxwell in the year 1831. Okay, next one, Wien bridge means we are having two sessions, nothing but R1C1, another one is R2C2. These are the two sessions required in, I mean, Wien-Bridge oscillator. First RC session will act as an high pass filter. Second RC session will act as an low pass filter. Okay, nothing but in high pass filter we are having a phase advance. In low pass filter we are having a phase delay. Already know high pass filter means it is used to allow high frequencies. Low pass filter means it is used to allow low frequencies. Okay, this session are being constructed to an Wien bridge circuit. Nothing but in terms of bridge, we are constructing the entire circuit to a bridge like this. Okay, like this, the circuit has been, redrawn to a bridge circuit. Okay, then this circuit being connected to an again op amp. Okay, so that two RC sessions are used to provide a phase shift of 180 degrees, and op amp is used to provide another phase shift of 180 degrees. Therefore, total phase shift is 360. The circuit can be oscillated to produce sinusoidal waveforms. In this, the frequency of oscillator can be determined as f is equal to 1 by 2 pi RC, and gain can be determined as condition for AV greater than T. If AV greater than T, the oscillations will occur. Okay. Now you simply can calculate as series impedance, nothing but R1 plus j omega C1, or ZP is equal to R2 plus, parallel impedance R2 into C2 by R1 R2 plus C2. You substitute this equation in, in terms of voltage divided in terms of feedback element, so that you can get the derivation for frequency. Another one is condition for sustaination. Again, the bridge can be balanced also determined as nothing but r1 r2 c2 by c1. By substituting r1 r2 is equal to r and c1 c2 is equal to c, again you can get that av is greater than 2. Av is greater than 2 means oscillations will occur. Okay. Another one is in Wien bridge oscillator. It is also known as Maxwell's bridge, famous. It is also known as Wheatstone bridge network also. Okay. The feedback it is used to measure the output voltage. Okay, after substituting all these equations in this, we can get the result, nothing but r2 into j omega c2 by r2 plus 1 by j omega c2. Like that you can substitute this equation in this factor, you can get the frequency. Another one is condition for sustained oscillation. Okay, now move on for a tuned oscillator. Nothing but a tuned oscillator means, again consider an op amp. Again, you substitute, you take three terminals, nothing but x1, x2, and x3 terminals. If x1, x2, x3, x3 are variable, x1, x2 are constant. Like that, we are having nothing but tapping. This is known as inductance tapping. This is known as capacitor tapping. Tuned oscillator are two types. Nothing but first one is Hartley oscillator. Next one is Colpitt's oscillator. Again, in this also you take an op amp. You simply consider the circuit with nothing but with the two sessions. Nothing but with two inductance L1. Another one is L2 with a capacitor tapping C. You've been circuit, and again in this also like this. Again, the tank circuit is used to provide a phase shift of 180, and op amp is used to provide shift of 180. Therefore, total phase shift is 360. Okay. You are having inner tappings, nothing but the electrical equivalent can be written as L equivalent is equal to LC, nothing but omega L equivalent is equal to omega C. You derived as mm, omega L equivalent is equal to omega C. Nothing but omega L equivalent is equal to 1 by the XC means nothing but 1 by omega C. Nothing but you move on our XL equivalent to nothing but L equivalent is equal to 1 by nothing, oh, sorry. Um, omega square is equal to 1 by L equivalent into C. Like that omega square, you write it as simply omega, that is L equivalent to C, nothing but root of omega. Already you have known that 2 pi f, 1 by root of L equivalent into C, nothing but f is equal to 1 by 2 pi root of L equivalent to C. This is the frequency of nothing but Hartley oscillator. Same similarly condition for sustain is a greater than 3. Okay. Simply we can write the Colpitt's oscillator is equal to 1 by 2 pi root of C equivalent into L. This is the frequency for Colpitt's oscillator. Now we move on for crystal oscillator. It made up of quartz material. For any microprocessor or microcontroller, this type of quartz material has been used. It values ranges from 20,000 to 2 power 10 power 6. Okay, and then crystal is used to depend upon piezo, nothing but when electrical phases is applied to faces of the crystal, it is used to produce mechanical vibrations, and mechanical vibrations are applied to face of the crystal. It is used to produce electrical vibrations. Nothing but it is used to convert electrical to mechanical and mechanical to electrical. Nothing but this conversion is known as piezoelectric property. Okay. Again, this can be crystal can be look like this. Crystal material look like this. This can be redrawn with an equivalent circuit, nothing but RLC. Another one is CM. Nothing but it is an equivalent circuit for crystal. Where R is the internal crystal, C is the crystal mass, and M is nothing but it acts as a mutual. So this is the circuit can be redrawn right. Crystal can be redrawn like this, and it is also as crystal can be used as series as well as parallel resonant frequencies. This can be constructed by using BJT. Another one is FET. Next, we move on our crystal circuit. We take a BJT, and collector we are having a RC, and emitter we are having RE, and limited by CE. Again, this crystal has been replaced like this. The RC can be replaced as RFC. Nothing but it has a coil. It acts as a DC, while decouple AC signal. Again, it is supply voltage with the basis. Okay, this is the transistor look like. Okay, this can be replaced in series. We are having a high frequency, whereas in parallel we are having low frequency. Okay, this is a crystal. Another we move on to UJT. Nothing but junction transistor. Already know. Nothing but it is a single junction. We are having two components, RT. Another one is CT. Another one is the basic symbol for UJT, emitter, V2, V1. Okay. It is used in the frequency conversion as 1 by 2 by RTCT 1 by 1 minus eta. The eta is intrinsic standoff ratio. It can be restricted to zero point 0.4 or 0.5. Okay, it is supplied with the VBV, nothing but base voltage. Okay, and across RT we are giving emitter voltage as VE. Okay, RT or CT nothing but time constant of the circuit. Again, VE can be determined as in terms of VB1, VB2 minus VD. This is a intrinsic standoff ratio. Nothing but VD means diode voltage. VB1 for V1 used to conduct a positive cycle. For V2 it is used to conduct the negative cycle. Okay. When V is less than VP, nothing but the voltage then the UJT will stop firing. When V is greater than V, the automatically UJT fires. We can get an output. So that entire UJT, we can observe the CT capacitor charging as well as the discharging, so that we can get an output as capacitor charging. Another one is discharging. Nothing but this is known as a sawtooth waveform. The UJT can also use as one of the famous applications is known as sawtooth waveform generator. In this capacitor charging will be takes place. Another one is capacitor discharge will be takes place. For P1, we are having a positive cycle. For P2, we are getting a negative cycle.